Okay, so this is the second technique of integration, which is integration by part. So function often arise as product of other function, and we may be required to integrate this product. So for example, we may be asked to determine the integration of x cos x dx. So here the integral is the product of the function x and cos x. So this is x and cos x. So what do we have here is a product between x and cos. So when we want to integrate them, we are going to use integration by part. So we are going to separate them into one of them called the u. Okay, so another one is called dv. So the formula is integrate u dv equal to uv minus integrate v du. So we're going to separate them into two, one called the u, one called the v. We are going to differentiate the u to get the u. Then we are going to integrate the v to get the v, and then we're going to substitute into the formula. Okay, so the first example, so we have x ex dx. So obviously we have to choose our u. So first step, choose your u and your dv carefully. So the way to choose our u is we correspond to the back. So we should check one by one what kind of function do we have. So whatever comes first, that one will become our u. So x over here is something called the polynomial. The e to the power of x here is called the exponential. So if you base on here, log p, so that means we have a p first. So u will become equal to x. dv will become the rest. So the whole thing will become dv, so dx, dx. So don't forget, you have to keep writing down the dx as well, because when we separate them, we have to separate them completely together with our dx. Okay, so that is the first step. Second step, we have to differentiate the u and then we have to integrate dv. So u is equal to x, so if I do du over dx, I'm going to get 1, which means du will be equal to dx. So following this, okay, so dv equal to ex dx, so to get to v, I have to integrate the exponent. So integrating the exponent, copy down the exponent, and then differentiating the power for this, or you can see we are going to take the coefficient of the x. So the coefficient is 1, ln of the base, so ln e. So what do we have as our v here is ex. So I already have u, dv, du, and v. So now the third step, we have to substitute into the formula. So we know that integrate u dv is equal to uv minus integrate v du. So that means if we integrate x dx dx, it will become u multiplied with v, so u multiplied with v here. So it will be x dx minus integrate, so v multiplied with du. So I'm going to get dx dx. So I already substitute into the formula. So the fourth step, I should try to simplify and solve. So look at the right hand side, can you simplify anything or not? So sometimes we do have some constants, so we bring the constant out. Sometimes we have to simplify the power inside here. As you can see, I only have one thing here, so that means I can directly integrate them. So this one, x ex, integrate e to the power of x. That will be the same thing over here, which is simply ex. So I know my answer here is ex plus with c. So it will become ex, x minus 1 plus with c. So for the second example, we have to integrate x squared cos x dx. So again, let's go to the first step. So we have to choose our u and our dv carefully. And again, choice of u depends on the fact. So let us check our function one by one to see what do we have. Okay, so x squared is something called a quadratic. So this is a polynomial function. So cos cos of x is actually a trigonometric function. So one of them is p, one of them is t. Therefore, I have to use p as a u. So u is equal to x squared. Meanwhile, dv is equal to cos of x dx. So you do make sure you take everything as your dv. So second step, differentiate the u, integrate the dv. So u is equal to x squared. So du over dx is equal to 2x. So that means du is 2x dx. Meanwhile, for dv, so v is equal to integrate cos of x dx. Okay, so integrating cos, so our v will be equal to sine of x. Third step, substitute into the formula. So integrating u dv is equal to uv minus integrate v du. So integrate, so copy down the question. So I have x squared cos of x dx equal to, so I have u multiplied with v. So it should become x squared sine of x minus integrate v multiplied with du. So we are going to have 2x sine of x dx. Okay, so the first step, simplify and solve. So I don't really have anything to simplify here except I can bring the 2 outside if I want to. But if you look at them here and here, we cannot use the basic rule of integration. So that means we have to use another technique, and let us do integration by part again. Okay, so that means u will now be equal to 2x because 2x is a polynomial. So du over dx is equal to 2. So du is equal to 2 dx. And then we have sine of x, so that is dv. dv equal to sine of x dx, which means the v will be integrate sine of x dx. Integrating sine, we are going to get negative cos of x. Okay, so substitute into here, we have x squared sine of x minus. So we definitely going to get two things here, u v prime minus v u prime. So negative 2x cos of x minus integrate v du, so negative 2 cos x dx. Okay, so simplify. What do we have is x squared sine of x negative negative, so this one will become positive of 2x cos of x negative negative negative, so negative negative positive positive negative negative 2 integrate cos of x dx. So now this one we can actually solve them by using the basic rule. So this is x squared sine of x plus 2x cos of x minus 2, differentiate cos, we are going to get sine of x, and of course plus with c.